Welcome to The Explainer. Ever wonder how an AI actually reads? Today, we're going deep, really deep, inside the code that translates our words into something a machine can understand. This is the fundamental stuff that makes all of modern AI even possible.
Okay, so let's just jump right in with a massive question. We interact with AI every single day that can chat with us, write our emails, and summarize articles. But how does it actually read our words to begin with? How does it go from a phrase like, "Hello world," to something a machine can actually process?
Well, the secret, it turns out, is a special kind of translator called a tokenizer. It's this absolutely critical component between our language and the machines. To really see how it works, we're diving into a fantastic article on DevGenius by an author named AI Alchemist _Abir, who takes us right under the hood to see how one of these is actually built.
First, to see where this tokenizer fits in, let's zoom out and look at the big picture. The source article is actually examining this really cool open source project called LLM-RS, and its goal is incredibly ambitious. It aims to run these massive, powerful language models right on your own local computer. No cloud, no giant data center.
Now, to make that happen, to get an AI to run on your laptop, it first has to understand text, right? And that brings us to the star of today's explainer, the tokenizer. It is the absolute first step in the entire reading process for an AI.
So what is this thing, really? You can think of a tokenizer as a highly specialized dictionary. It takes a sentence, chops it up into smaller, predictable pieces called tokens. These could be words, or even just parts of words or punctuation, and then it converts each of those little tokens into a unique number that the AI can actually work with.
At its core, the whole process is a pretty simple pipeline. You start with regular old text. The tokenizer then gets to work, almost like a chef, precisely slicing that sentence into these meaningful chunks, the tokens. And finally, it just swaps each token for a number, creating this nice, clean sequence that the AI is built to understand. Text in, numbers out.
Okay, but this is where it gets really interesting, seeing how this whole process looks in actual code. So let's zoom all the way in on this tokenizer.rs file from the LM.rs project and see how it's built using the Rust programming language.
You know, the author of our source article has this personal mission statement that I just love. Code complexity, I make it elegant. So let's see how they take this really complex idea of a tokenizer and actually translate it into some elegant, understandable code. Okay, this table simplifies the code so we can see what's going on. First, the code reads the tokenizer's dictionary file right from the computer's hard drive. Then, from the very first few bytes of that file, it figures out the vocab size. That's basically the AI asking, how many unique words do I know? It also identifies special tokens, like BOSS, which stands for beginning of sentence. This is a crucial little flag that tells the AI, hey, a new thought is starting right now. And you can even see the developer's thought process here, with this commented out line for max token lin. That's a little note to self, a plan for a future feature.
Now, you might be asking yourself, why go through all this trouble in a complex language like Rust? Well, this brings us to one of the most critical points in all of modern AI development, the absolute, non-negotiable need for performance, the need for speed. Look, while other languages might be a bit easier to get started with, Rust is built from the ground up for two things: raw speed and memory safety. When you're processing potentially billions of tokens for a large language model, that efficiency isn't just a nice-to-have, it's completely essential. Rust makes sure the program runs as fast as possible without crashing, which is critical for these demanding AI applications. And this whole quest for speed, it gets to the heart of a major goal in AI today. It's not just about creating smarter models, it's about making them efficient enough to run anywhere, not just in a massive data center, but right there on your machine. That is the real quest.
And that obsession with performance really matters. An unoptimized tokenizer could mean waiting seconds for a response from a local AI, making it feel sluggish and clunky. But with highly optimized code like this, you get instant interactions. It feels seamless. This is the nitty-gritty engineering that makes powerful AI feel accessible to all of us. And the interest in this stuff is huge. DevGenius, the publication that shared this deep dive, has over 28,000 followers, which just shows you how many people are hungry for this kind of high-performance code.
So let's do a quick recap. Tokenizers are the essential translators that turn our language into numbers for an AI.
They're a fundamental building block for every large language model. For them to work well, especially on our own devices, performance is king, which is why a language like Rust is chosen. But maybe the biggest takeaway is that code is so much more than just instructions. It tells a story of human intention, right down to a single commented out line planning for the future.
Which leaves us with a final thought to chew on. This tokenizer code, this is the stuff that makes today's AI tick. But as AI continues to evolve and gets exponentially more powerful, what kind of translators will it need next? What new, elegant code will developers have to invent to unlock the next generation of artificial intelligence?